Okay, for this experiment, we're going to use this funky little data harvester. The old ones will only allow you to time between one light gate and another, which isn't very useful. To actually get that to work properly for this experiment, you would need about 6 light gates and 3 data harvesters for each one. I'm going to set that up later to see if it actually works and if that's doable, because at the moment we've only got one of these. Hint, hint, Sam, they are awesome, and I'll show you how awesome they are in a minute. So when we set this up, we want to go to timing, which is this one, the clock. Let it do its magic. Okay, so I don't know if you can read that, but it gives you a bunch of options. How do you want to record the data? And I want speed and velocity at this point. And then I go to next, and I want speed at A then B, because I want to measure the speed of the trolley through this one, and then the speed of the trolley through that one. Okay, so I want at A then B. I click next. Okay, you then measure the length of your card. This one. This is conveniently 100 millimeters, which is this is already set to. If not, you just change it. And you hit next. This is really difficult to do through a camera. YouTubers, I salute you. So time in seconds, speed in meters per second. Hit next. Now, it also then gives you select columns to display. Speed at A, speed at B, that's what we're measuring, that's what we want. Also, allows you to measure time from A to B. Hit finish. And now it's going to give you these 3 bits of data, which is fabulous. If you hit the little green button, okay, once your cart is lined up, I'm just going to remove, I've got my 1 Newton mass attached, remove my mass and watch the trolley go. Hit that light gate, through that light gate. Now what it's given me is speed at A, which is the first gate, 0.13729 meters per second. The speed at B, 0.3125 meters per second, and importantly the time between them, 2.28923. So this now allows you to calculate the change in speed and divide it by the time taken, which gives you the acceleration. The students are then able to plot acceleration versus mass. So they're going to have taken the mass of the trolley, and for the first part of the experiment they're going to add more masses. You can leave the data harvester running. What you can do is then pull this along outside of the gates and pop it back in front of the gate. Make sure your mass is still there, it still is, and then you let it go. There you go. So now, as you can see on the graph, the time between them has gone down. The speed at B, roughly the same. Speed at A, slightly higher. It's because it's a physics experiment. And where would a physics experiment be if it all went right completely? So, you then just add masses. Keep adding masses, and you do the same thing for each one. So, things that go wrong with this experiment is string comes off the pulley, mass comes off the string. So make sure you put a chock over there, reattach your pulley. This mass, by the way, always stays the same in this version of the experiment. And then make sure your trolley's aligned. Make sure this is ready to go. It will go into screensaver mode, so just poke it with the plastic stick. Be careful with the plastic stick, we've only got one. Okay. Take the chock away, and off it goes. Okay. You'll notice I made a massive error there by allowing the card to already be through the first gate. Oops. So, try that again. Okay, make sure it's not on. Take it away. And off it goes. You have to make sure that one didn't work because this wire's in the way. So all of these things are pitfalls. And making sure that these don't affect the timing.
Because it slowed down massively there, 14 seconds.